to go in Unit 2B. So Tuesday we talked about the quadratic formula. Yesterday we talked about complex numbers and talking about negative square roots and how we deal with negative square roots and all of those different types of things. So these last 2 days, we're going to spend simplifying square roots. And using the square root method with i's. And tomorrow we're going to do the quadratic formula with i's. So really becomes really a good review of really two methods we've used to solve quadratics, the square root method and the quadratic formula. But now we're just putting an additional piece to it where underneath the square root symbol we're going to have negative 32 or negative 25 or something like that. So we have to deal with them with the i's. So obviously our whole goal for today is to use the square root method to solve quadratics, and this time we're going to have some i's involved as well. So just a little bit of review from yesterday, the imaginary unit. We talked about this yesterday, so you probably already have it in your notes. Just kind of want to talk about it real quickly again. Remember, I is the imaginary unit. So the square root of negative 1 is equal to I. We'll use this a lot more today. This is going to be what's used a majority of today. The square root of 1 is equal to I. And then, of course, then I squared is equal to negative 1. And we worked with that a lot yesterday when we were adding, subtracting, multiplying, and dividing. So we're going to kind of go the other way with it today. So we looked at these first two examples yesterday when we were doing some examples. But for those of you that weren't here yesterday, just a quick explanation. And those of you that were here, if you've forgotten, remember what we can do with the square root of negative 25. It's the same thing as the square root of 25 times the square root of negative 1. Square root of 25 we know is 5. And because we said the square root of negative 1 is equal to I, we can change the square root of negative 1 to I. So then the solution to this is 5i. And you're done. Okay. Now, you don't, obviously, that's just teaching thing. As to writing it out like that, that's just part of teaching it. Obviously, now if you see the square root of negative 49, you know the square root of 49 is 7. It's a negative, so we have to make it an I. And that's perfectly fine. Obviously, I don't expect you to write 25 times the square root of negative 1 every time. That would just be too much work. Yeah. That's not it. Oh, this would be horrible. Now, I get hit. If we look down at the bottom ones, these are a little bit different than what we talked about yesterday. But if we have 5 times the square root of negative 121. So we've got this 5 sitting out here now. But now we have to deal with this square root of negative 121. So we're going to have to multiply by something because two things beside each other means to multiply. So we have to figure out what the square root is. Ooh, good timing. With like 30 seconds to spare. Square root of 121, I think, is 11. Right? So that's 11i. So 5, now we can multiply these together. We can multiply a real times an imaginary. So we've got 55i is the solution for this one. Okay. Why don't you go ahead and do number 4. See if you can figure out what number 4 is. Give you a quick, it's only take about 15 seconds. So we got the 2 sitting out there. Square root of 36 is 6. We've got a negative, so that's 6i, so 12i. Good? All right, so that's kind of, again, evaluating just those square roots. Okay, so now let's get into a little bit more complex ones where, okay, now they're not going to be perfect squares. So 12's not that perfect square. We still got a negative, but now we have to think about it in our other way. Okay, Okay, we know we're going to do the I thing. It's negative. The I thing is going to come out. So let's just deal with 12. So again, a good review of how we how we take care of the 12, or you guys do prime factorization. So remember, that's 4 times 3. And at this point, we've done these enough now that 4 is a perfect square. I mean, you can break it down to 2 and 2 if you want to, if you need to do that, so you see its pair. But honestly, we've done enough of these now that if you see a perfect square show up, you should just automatically mean that means I get to take a 2 out. Square root of 4 is 2. Okay, so this is going to be equal to the 2 square root of 4 is 2. 3 doesn't have anything, so I got to leave the 3 underneath there, but it's negative. So the answer to this is 2i radical 3. And that's your solution. And again, if you have to do the 2 and 2, there's your partner, it comes out, that's fine. There's nothing wrong with that. Okay? Number 6, the negative square root of negative 96. Okay, and notice this negative is not underneath the radical symbol. So I can't lose that. That's got to come along for the ride. That doesn't make it an I. Underneath the radical makes it an I, an imaginary unit. That doesn't. Okay, so we got to deal with 96. It's 3 times 32. 32 is 16 times 2. Do I have to go any further? No, 16 is a perfect square. So what's the square root of 16? 4. So I've got the negative. I got to bring that negative with. The square root of 16 is 4. It's negative. I know I have to have an I sitting there. Times the square root of. I've got a 3 here and a 2 here. 3 times 2 is 6. So there's my solution for this one. Negative 4i radical 6. And again, if you have to do the 4, 4, 2, 2, 2, 2, that's fine. There's your partner, bring it out. There's your partner, bring it out. 2 times 2 is 4. Okay. Go ahead and do 7 and 8. Give you about a minute and a half. Should be long enough to do those. Again, all we're doing now is getting kind of ready for what we're going to do today. That's part of what you're going to do today. But really our whole goal is to be able to solve quadratics using the square root method with i's. So we're getting there. I think I looked at the weather app yesterday. I think they said it's supposed to be like 50 degrees on Sunday. Yes. You know what that means? Going and getting lost in the woods for like 2.5, 3 hours for a run. Doesn't that sound like a good way to spend a Sunday? Listening to audiobooks. So I've got the 5. So we've got 28. 28 is 4 and 7. I like the 4 because we know the square root of 4 is 2. So that's going to be 2i radical 7. 5 times 2, so 10i radical 7. Okay. 45, just 45. There's no negative with it. So we just do it how we always do. 9 times 5, so 3 radical 5. It's always more fun when you pick perfect squares. I mean, you could go 15 and 3, but then 15 is 3 and 5. You still got your 3s, but yeah. Okay, so like I just said a few seconds ago or minutes ago, this is all kind of leading up to really what we want to be able to do today is we want to be able to solve equations by taking the square roots. Okay? And some of them are going to deal with i's, some of them aren't. So remember when we're solving equations, by taking the square roots. First thing we're going to do, because really all we're going to end up with a and c's today. You're not going to have any b values today. It's just going to be a's and c's. And anytime you have the a value, the one out in front of the x squared, and the c value, the constant alone, this is the way I would always do them. Okay. Remember when you're doing it in this method, the first thing you want to do is isolate the a value, the x squared. Okay. How do we get rid of the squaring something? We take its square root. So we take the square root of both sides. But remember, when we take the square root of both sides, we have two solutions. It's plus or minus whatever the square root of that is, which obviously is 3. So no I in that one, but it's just a good reminder of how we do these. And anytime you have an a and a c value, this is the way to do it. The square root method. I'd never do it any other way. I wouldn't factor this. I can some of them. Square root method is the way to do it if you just have an a and a c and there's no b in there. All right, so if we look at this one, we've got x squared plus 4 equals negative 5. We have to isolate the x squared. Whoa. I'm getting ahead of myself. Have to isolate the x squared. So that means I need to subtract 4 from both sides. So you get x squared equals oops, I got ahead of myself again. Negative 9. Right now, we take the square root of both sides. Bless you. Remember, it's going to be plus or minus. Square root of negative 9, square root of 9 is 3. It's negative, so you have to put the I in there. There's your solution. And leave it just like that. Okay. Eventually, like a month from now, probably longer than that, second semester, we're going to start to learn how to graph these quadratics. That's what the honors kids are doing right now with the next unit. They're learning how to graph these. And that's what we're kind of leading up to. How do we go about graphing different polynomials? This is eventually going to help us do that. Okay. Next one. It's getting a little bit more complex, but not too bad. Negative 2k squared plus 2 equals negative 114. And remember when you're solving equations in general, and again, we're trying to isolate the k squared. Get rid of any addition or subtraction to your variable first, and then get rid of any multiplication or division. So we're going to go ahead and subtract 2. So that's negative 2k squared equals 112. I still have negative 2 being multiplied by my variable, so I need to divide by negative 2. So now I have k squared equals negative 56. Thank you. We got k squared equals negative 56. Take the square root of both sides. So k is going to equal plus or minus the square root of negative 56. So now that's not a perfect square, so we have to deal with it. I think 4 goes into it. 8 and 7. We can do that too. 8 and 7. So 8 is 4 times 2. Now I've got my 4 sitting there, so I'm not going to do it anymore. So we've got plus or minus. The square root of 4 is 2. It's negative, so we put our I times the square root of, we've got a 2 and a 7 that are lonesome. We got to make them unlonesome. 14. That's your solution. Again, notice the negative's gone, all of that kind of stuff. It's kind of colorful. Get rid of any addition or subtraction first to your variable. Then get rid of any multiplication. Then deal with your square roots after that. Okay. Go ahead, give number 13. Oh, let's do number 12. Go ahead, do number 12. See what happens if you remember how to deal with fractions. It's getting a little bit of puzzling looks. It's okay. So 25n squared, we have to add 10. I think everybody was good with that, right? So that's 36. Divide by 25. Okay, so we've got n squared equals 36 over 25. Now what do we do? Well, we take the square root, right? We take the square root of this. Are we going to have an imaginary unit? No, there's no i's in this one. That's okay. So n is going to equal plus or minus. What do you notice about 25 and 36? What are they? Perfect. Yeah, so what's the square root of 36? 6. What's the square root of 25? 5. There's your solution. As remember, we could rewrite this as the square root of 36 over the square root of 25. And if they're perfect squares, we just want to find the square roots of those and go from there. Okay, nice job. Last one, and I think we'll be good to go. We'll get one with another I, and I think this one's going to be nice and a nice number.
Watching the way I got up to the top of the hill, and it turns into a campground to get to the other side of the trail. So everybody just like gravel road, not paying attention. Hit a hole, wedged out, and like this whole
I walked through.
I remember, I think it was Owatana's course. No, yeah, it was Owatana's course. There was like a hole on one of the corners, and I remember falling in it. This was freshman year.
They hurt. So n squared equals negative 16. Take the square root of both sides. So n is equal to plus or minus. Square root of 16 is my most talkative class all day. 4. It's negative, so I. Solving quadratics equations by taking the square roots with i's in there today is what we wanted to be able to work on. And I think we're pretty good. Okay. Your assignment inside Schoology, and I've got a paper copy of it today, is going to make sure you're good with this. Tomorrow we're going to do the quadratic formula using complex numbers. And that is the last part of the chapter.